Hello everyone. Today we will going to see some practice questions from the chapter Physical and Chemical Equilibrium, and this is our part 4. So let's start. Disclaimer slide which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. This is our index slide. So today we will cover some practice questions from question number 25 to 32. Let's start with question number 25. XY2 dissociates as XY2, giving you XY and Y. When the initial pressure of XY2 is 600 mmHg, the total equilibrium pressure is 800 mmHg. Calculate K for the reaction, assuming that the volume of the system remains unchanged. This is the highlighted point, that the volume of the system remains unchanged, and the initial pressure of XY2 is 600 mmHg, and the total pressure at equilibrium is 800 mm of Hg. We have to find out the K. Options are 50, 100, 166.6 or 400. You have 10 seconds to solve this question. After that, we will see the answer. Okay. So our correct answer is option B, that is 100. So this is the reaction given, dissociating reaction. XY2 dissociates into XY and Y. Initially, the pressure of XY2 is 600 mm of Hg and XY and Y are 0 and 0. Now at equilibrium, the XY2 pressure will become 600 minus P and XY will become P and Y will become P. So total pressure will become 600 minus P plus P plus P, and we know that total pressure is given as 800 mm of Hg at total at the equilibrium. So 800 is equals to 600 plus P, and P is coming out as 200 mm of Hg. Now we know that the rate constant, equilibrium constants in term of partial pressure is the pressure for the product, that is XY and Y. So P and P into P divided by the concentration, or sorry, pressure of reactants, which is 600 minus P at equilibrium. So P into P divided by 600 minus P. P we have 200 mm of Hg, so we put it in this equation. We have K equals to 200 square divided by 600 minus 200, that is 400. And on solving this, K is coming out as equals to 100. And thus our correct option is B option, that is 100. Okay, move on to next question. Question number 26. A vessel at 1000 Kelvin contains CO2 with a pressure of 0.5 atmosphere. Some of the CO2 is converted into CO, carbon monoxide, on the addition of graphite. If the total pressure at equilibrium is 0.8 atmosphere, the value of Kp is. We have given the total pressure at equilibrium, and we have given that the pressure of a vessel initially 0.5 atmosphere, and some of the CO converted to CO on addition of graphite, and we have to find out the Kp, that is the equilibrium constant in terms of pressure. Options are 1.8 atmosphere, 3 atmosphere, 0.3 atmosphere or 0.18 atmosphere. You have 10 seconds to solve this question. After that, we will see what will be the answer. Okay, so the correct answer is option A, that is 1.8 atmosphere. So we have given this equation, CO2 plus C will give you 2 molecules of carbon monoxide. Now we have given that initially the pressure of the CO2 is 0.5 atmosphere, and we have given that the total pressure at equilibrium is 0.8. So at equilibrium, what will happen? The CO2 pressure will become 0.5 minus P, and the 2CO pressure will become 2P. Because 2 moles of CO are present, so the total pressure will become 2P. And now you can see that this is a case of heterogeneous equilibrium, as you can see that the phase of the reactants and products are different. So the carbon in the solid form being in solid is not considered in this reaction, in this pressure equation. So the total pressure will become equal to pressure of CO2 plus pressure of carbon monoxide. So pressure of reactant plus pressure of product. Pressure of CO2 at equilibrium is 0.5 minus P, plus pressure of CO at equilibrium is 2P. On adding, we have total pressure, which is given as 0.8 atmosphere. So 0.5 minus P plus 2P is equals to 0.8. And on solving this, we have P is equals to 0.3 atmosphere. Now, the pressure of CO2 is 0.5 minus P. We have P. So 0.5 minus 0.3. So pressure of CO2 is 0.2 atmosphere. Similarly, the pressure of CO, carbon monoxide, is 2P. That is 2 into 0.3, which is 0.6 atmosphere. And hence, we can find out the equilibrium constant in terms of pressure, which is partial pressure of CO2. Partial pressure of product, that is carbon monoxide, to the power 2, because 2 is the stoichiometric coefficient, divided by partial pressure of CO2 molecule. So partial pressure of CO, carbon monoxide, is 0.6 square, 0.6 into 0.6, divided by the partial pressure of CO2, which is 0.2, right here. So on dividing this, we have Kp is equals to 1.8 atmosphere. And hence our option A, 1.8 atmosphere, is the correct answer. Okay, let's move on to the next question. Question number 27. Ammonium carbamate decomposes as. We have this as ammonium carbamate. It decomposes into 2NH3 plus CO2. For this reaction, Kp is given, which is 2.9 into 10 to the power minus 5 cubic atmosphere. Now, if we start with 1 mole of compound, the total pressure at equilibrium would be. This time, we don't have the total pressure at equilibrium, we have to find that. Options are 0.0766 atmosphere, 0.0581 atmosphere, 0.0388 atmosphere, or 0.0194 atmosphere. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option B, 0.0581. So this is our reaction, we know, given in the question. So at equilibrium, the partial pressure of CO2 is P, let's suppose it is P, and that of NH3 will become 2P, right? And whatever, because we are starting with the 1 mole of the compound, as it is given that we are starting with the 1 mole of a compound. So initially 1 0 0, and finally it will be 1 minus x and 2x and x. But if we talk about the partial pressures of these products and reactants, so the at equilibrium the partial pressure of CO2 will become 2p, P, and the partial pressure of NH3 will become 2p. Now we know that Kp in terms of partial pressure is the product partial pressures multiple divided by the reactant partial pressure. So P of partial pressure of NH3 to the power 2 square whole square into partial pressure of CO2. Partial pressure of NH3 is 2P and partial pressure of CO2 is P. So we take the square of 2P because 2 as stoichiometric coefficient is present of NH3 in the reaction. So 2P whole square multiplied by P, it is coming out as 4PQ, right? and divided by the partial pressure of reactant, right? But as we are starting with the 1 mole of the compound, so it will be 1. The partial pressure of this we take as 1, because also it is in solid form, so the partial pressure of this reactant will not be considered, so only these will be considered. So this will automatically will be equal to 1, and the Kp will become equal to 4p cube, which is equals to 2.9 into 10 to the power minus 5, because Kp value is given already. So this will become equal to 4p cube, and now we can find out that p cube is equals to 2.9 divided by 4, which is 7.25 into 10 to the power minus 6. And from this we take the cube root of 7.25 into 10 to the power minus 6. So p will become equal to 1.935 into 10 to the power minus 2. Right now, the total pressure, which is 3p, because p plus 2p, which is total pressure at equilibrium, so it will be 3p. So 3p will become 3 into p, which is 1.935 into 10 to the power minus 2. Now it will be equal to 5.81 into 10 to the power minus 2, and it is equals to 0.0581 atmosphere. Right, so total pressure is coming out as 0.0581 atmosphere, and hence our B option is correct for this question. Okay, let's move to next question, question number 28. In reaction, A plus 2B will give you 2C plus D. Initial concentration of B was 1.5 times of the concentration of A. But at equilibrium, the concentration of A and B became equal. The equilibrium constant for the reaction is, we have to find out the equilibrium constant for this reaction. Options are 8, 4, 12 or 6. So you have 10 seconds to solve this question. After that, we will see what will be the answer. Okay, so the correct answer is option B, that is 4. So let's suppose that the degree of dissociation is equals to x in this case. So this is our reaction. A plus 2B will give you 2C plus D. Initially, we say that the initial concentration of B was 1.5 times of A. So let's suppose A is initially 1 mole. So 2B will become equals to 1.5 moles. And 2C and D are 0 and 0. Now at equilibrium, the degree of dissociation x, so 1 minus x, and for B it is 1.5 minus 2x, for 2C it is 2x, for D it is x. Now it is mentioned in the question that at equilibrium the concentration of A and B became equal. So 1 minus x is equals to 1.5 minus 2x, and on solving this x variable equation, we have x is equals to 0.5. Now equilibrium constant for the reaction, if we find out, it will be the concentration of C to the power 2 into the concentration of D, and C and D are products, divided by the concentration of reactants. So concentration of A into concentration of B to the power 2. Putting the values of all these at equilibrium. So C is 2x, so 2x whole square. D is x, so x, divided by 1 minus x for A and 1.5 minus 2x whole square for B. And on solving this fraction, we have Kc is equals to 4. Right? We just put the as x is equals to 0.5, which we just calculated. And on solving and multiplying and dividing, we have Kc is equals to 4 finally. So our correct option is option B, that is 4. Okay, let's move to the next question. Question number 29. The equilibrium constant at 298 Kelvin for a reaction A plus B give you C plus D is 100. If the initial concentration of all 4 species were 1 molar each, Okay, so the initial concentration is given for all these species, products and reactants, which is 1 molar. Then equilibrium concentration of D we have to find out. Only the equilibrium concentration of D we have to find out in mole liter inverse. Options are 0.818, 1.818, 1.182, or 0.182. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct option is option B, that is 1.818. So we have given this reaction A plus B giving us C plus T, and it is also given that the initial concentration of all the four species were 1 molar. So at initially T equals to 0, A is 1, B is 1, C is 1, and D is 1. Now at equilibrium, if we consider the degree of dissociation as x, then the A will become 1 minus x, B will become 1 minus x, C will become 1 plus x, and D will become 1 plus x. Now we know that the equilibrium constant for this reaction will be the concentration of products divided by the concentration of reactants. So CD divided by AB, and C is 1 plus x into D is 1 plus x divided by A is 1 minus x into B is 1 minus x. So it is 1 plus x whole square divided by 1 minus x whole square. Now we have also given the equilibrium constant, which is 100 in the question. So 100 is equals to 1 plus x upon 1 minus x whole square, or we can say on taking square of both side, under root of both sides, we can see that 100 is the square of 10, and this is already in a square, right? So we just reduce it into the simpler form as 10 is equals to 1 plus x divided by 1 minus x. What we did, we just interchange the power here. So 1 plus x upon 1 minus x is in square. So square on the left hand side, it will become half. So under root of 100 will be 10. So it will become 10 equals to 1 plus x upon 1 minus x. And now it is a simpler equation. We just multiply 10 by denominator. So 10 minus 10x equals to 1 plus x. And on solving for the variable x, we have x is equals to 9 by 11, which is equals to 0.818. Right? Now in the question, what we have asked, that the equilibrium concentration of D. So at equilibrium, the concentration of D is 1 plus x. So 1 plus x is equals to 1 plus 0.818, which is 1.818. And hence our B option, that is 1.818, is the correct one for this question. Okay. Let's move to question number 30. Match standard free energy of the reaction with the corresponding equilibrium constant. We have given column 1 and column 2 here, and in this we have given rows. So in the column 1 we have A, B and C, and we have given the different values for del G, which is greater than 0, less than 0, or is equals to 0. In the column 2 we have given the value of equilibrium constant, which is greater than 0, equal to 1, equal to 0, and less than 1. And we have to match the column 1 to the column 2. Options are A is 2 for 2, B for 1, C for 3, A for 3, B for 4, C for 1, A for 4, B for 1, C for 2, or A for 3, B for 1, C for 4. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so let's see. So the correct answer is A is for 1, B is for 1, A is for 4, B is for 1, and C is for 2. So if K is greater than 1, the reaction favors the formation of products, and del G is become negative, that is spontaneous. So K is greater than 1 will become will come in this case. So for K positive, the reaction favor the formation of product, and del G become negative for 4. So B is for 1, as we can see here. B is for 1. If K become negative, less than 1, the reaction favors the reactants, and del G is become positive. So for K less than 1, we have del G is positive. So A is for 4. A is for 4. And if K is equals to 1, the system is at equilibrium and del G become equal to 0. So if K is equals to 1, del G become equals to 0. So C is correspond to 2, right? So our C option is the correct answer, is the correct match given for column 1 and column 2. Okay, let's move to question number 31. On increasing the pressure, in which direction will the gas phase reaction proceed to re-establish equilibrium is predicted by applying the Le-Chatelier's principle. Consider the reaction N2 plus 3H2 will give you 2NH3. And which of the following is correct if total pressure at which the equilibrium established is increased without changing the temperature? So if we increase the uh, sorry if we increase the total pressure, or if the total pressure at which the equilibrium established is increased without changing the temperature, so we don't change temperature, we just increase the total pressure at which equilibrium has established. So which of the following options are correct? We have to choose the correct one. Options are: K will remain same, K will decrease, K will increase, or K will increase initially and decrease when pressure is very high. So you have 10 seconds to solve this question. After that, we will see what will be the answer. Okay, so the correct answer is A option, that is K will remain same. So in the reaction, you can see N2 plus 3H2 will give you 2NH3. If the total pressure at which equilibrium established is increased without changing the temperature, so you can see the temperature is not changing. So K will remain same because K changes only when the temperature is changed. K is only dependent on the temperature. So as you can see that it is mentioned that the temperature is not changing. So K will also remain same. Hence option A is the correct answer. Moving on to question number 32. In the given reaction, 2x plus y will become z and plus 80 kilocalorie energy will be released. Which combination of pressure and temperature gives the highest yield of z at equilibrium? So we have to choose the correct combination. Options are 1000 atmosphere and 500 degrees Celsius, 500 atmosphere and 500 degrees Celsius, 1000 atmosphere and 100 degrees Celsius, or 500 atmosphere and 100 degrees Celsius. You have 10 seconds to solve this question. After that, we will see what will be the answer. Okay, so the correct answer is option C, that is 1000 atmosphere and 100 degrees Celsius. Since the moles of product is less than the moles at the reactant, you can see here, right? Because it is here it is only 1 at the product side, here it is 2 plus 1 3 at the product side. So moles at product side is less than moles at reactant side, and the reaction is exothermic because 80 kilocalorie energy is releasing. So high pressure and low temperature favor the forward reaction, and to favor forward reaction the pressure should be 1000 atmosphere and the temperature should be 100 degrees Celsius, because we check from the options that which option suits the high pressure and low temperature combination. So it will be option C, that is 1000 atmosphere highest pressure and the temperature of 100 degrees Celsius, that is lowest temperature. And thus our option C is the correct answer. Okay, thank you.